currently being recorded. Anybody here who wants to join along at home, I've got the link to the RailsGoat GitHub project and the Brown Bag Chatter Slack room. We'll do all our chatter in there today as well. If you have any questions, feel free to ping me in there. I've got it up. I should be able to see it, no problem. And I presume my audio is good, video good for everybody?
Your audio and video are good, and I am going to drop my video. I'll be relaying you any questions out of the Brown Bag Chatter room that come up.
All right, excellent. All right, well then let's go ahead and get started. We slated an hour for this, but we're going to get cut short at about 45 minutes today due to a meeting after us. So let's dive straight in. Feel free to, again, pull the RailsGoat project from GitHub. It's up on my screen right now. You can clone that. It's not necessary for the presentation today, but if you want to poke around, feel free to go ahead and grab that while I do a bit of introduction on the whole subject here. So this is probably beginner to intermediate level for no other reason than I'm not actually a security expert. Starting a few years, or last year's audit for PCI and payments, we decided to use RailsGoat as our tool for doing security training. And I just re-upped my training last week or so, which is why I decided to go ahead and do a brown bag on this while it's still fresh in my head. Feel free to ask questions though, and just don't be disappointed if I say, you know what, I'm not really sure. The goal of this presentation is to give you a quick tour of the RailsGoat tool. We're actually going to go through some vulnerabilities in the app, do some actual hands-on, but this is not meant to be any kind of comprehensive security overview of even just Rails. Security, obviously, for those who know, is a deep topic and something which it's usually a good idea to have security experts around. And I, again, am not a security expert. Again, we're in the Brown Bag Chatter channel on Slack. Feel free to ask questions as we go. And here's the intro part. So OWASP, for those of you who don't know, this is their homepage. They are a nonprofit organization. OWASP stands for the Open Web Application Security Project, and they gather together all sorts of information related to online security. And in particular, we'll be looking at one of their products, which is their top 10 list. They updated this in 2013. Prior to that, it was updated in 2010. So they update it as need be with the top 10 vulnerabilities found in web applications in real life, according to frequency. And as part of this, Ken Johnson and Mike McCabe, who both used to work here at LivingSocial, started the RailsGoat project. After doing some work, sorry. If you could, please, I'll try to keep my thing collapsed, but sorry, that GIF in Slack was distracting. So no GIFs if possible, please, even though I love them. Anyway, so Ken Johnson and Mike McCabe started this project. It's a vulnerable Rails application, so you can get some hands-on experience with seeing some of this stuff. You'll see me as a contributor there only because when I first picked this up in 2013 for training, I added some specs because I found it helpful for myself to be able to actually exploit the vulnerabilities in code and realize that it was actually pretty simple to do, and those would make good specs. So I contributed that to the project. And so let's get into it. So I'm running RailsGoat locally, and I'll be referring to its instance here in Chrome. And as well, I'm looking at the code here in RubyMine. So the RailsGoat app really has kind of two ways of going. If you get to the home page here, you'll see that there's a tutorial home, and the intention is really you could go two different ways with the app. One is to just browse through the tutorials. Each vulnerability from the top 10 gives you a description of what it is, and you can choose what level of spoilers you would like to view. You can get hints and poke around at the site. But it also includes fully documented bugs and solutions for each of the vulnerabilities. So you can kind of browse it that way, or if you just want to try to hack on the site and go at it, you can go at it that way. If you don't want spoilers, you probably should not look at the source code because they include vulnerability solutions commented out next to where the problems usually are. And we actually talked about that. Since the tutorials have all that information, I propose that perhaps we take out all that sample code. And Ken Johnson is going through the process of kind of overhauling the site right now. Also, if you do go through the site to try and hack on it, sometimes I have expectations working with the tool that everything should just work, and that if I fix a vulnerability, then everything should work. But sometimes there are side effects from other vulnerabilities that got fixed. So it's kind of a difficult project to make sure it's always 100% smooth sailing when code's being changed underneath, and you can't control what order vulnerabilities get fixed in and whatnot. So if you do hack on it, just grant the project a little bit of patience, or even better, grant the project some PRs, because as we all know, open source projects like those. So again, we're going to walk through a bunch of different examples here, so let us jump in. Like I said, we'll be looking at a lot of the examples through both RSpec and through the browser. These RSpecs are built using Capybara as well. If you're not familiar with Capybara, it's a Ruby gem that basically gives you headless drivers or drivers for different web browsers, and a DSL that lets you write tests or code to automate your browsing experience. That's pretty straightforward. And as you'll see in a number of these examples are really condensed, and I found the specs a nice way to look at how the attacks play out. So let's start with the first one. The number one on the top 10 list are injections of sorts, and SQL injections are, of course, a well-known version of that. So again, I'm going to walk through the RSpec, and then we'll see this one in action through the browser as well. All the RSpecs have a setup here, which basically just makes sure that everything's in isolation. It's going to reset all of our users and hand us off a normal user. In this spec as well, we're grabbing an admin user. So there's our setup. Then we can go into the attack here. We're just double checking that the admin user is in fact an admin. But we're going to log in as a normal user and visit the account settings page. So I'm going to break off to the browser here and actually sign up for an account as a normal user would using this email address, just some test data, password of password, and now it's created an account. So the RailsGoat test site is set up as like an HR site for employees. It's all dummy data. As you can see, these gauges are changing dynamically. And there's all sorts of different forms here, pages on the site for benefit forms, 401k info, etc. And this first SQL injection attack is going to happen on the account settings page. So here's what the account settings page is. This is simply where you would update your profile, your name, password, email address. So we go back to the spec. We can see that after we've visited the account settings page, we can start our SQL injection attack. And so the first thing we do is we're going to change our email address, set the password, which is just a convenience to make sure that the submit works. And then here's the actual attack. On this form, there is a hidden user ID field that's set to your current user ID, and that's where our SQL injection attack can happen. If we override that value, let's see what that value is normally. I'm going to go to inspect element on this text box, and we can see here's the hidden field. And so this value currently is set to 6, which is my user ID, which you can see right here. And so this page was designed on the presumption that that value would just stay there and we wouldn't be able to affect anyone else's user account. But if we override that value with this string, then we can do a SQL injection attack and in fact set the password and email address for an admin account and take that over. So I'm going to go ahead and execute the spec. If it passes, that means the vulnerability exists, which it does. You can see here we're doing some assertions at the end where we're grabbing the first admin user out of the database, verifying that its email address is now set to joe.admin, which is what we set it to up here, and that it is an admin account. I'm going to show you the same attack through the browser. Copy that text, go into here, delete that value, paste that in. Now if I fill in, I need to change the email address, otherwise this won't work. It'll find the duplicate. So I'm going to make this admin@a.com. Password is password. Submit. Now I should be able to log out and log in as admin@a.com. Password is password. You look over on the left here, I now have access to admin functionality and I can do all sorts of nefarious things. So to fix this, we need to have some more common sense, some more goodly coding stuffs. I'm going to go to the users controller. And so here's an example where RailsGoat includes the fixed code right alongside the bad code. So we need to, the SQL injection happens right here. Anybody who's worked with Active Record has seen this, that Active Record internally will protect you from injections if you use it correctly. This is an example of using it incorrectly to where the where clause of the select statement is going to be injected. And in fact, if we go out to the Rails console, we should be able to see, yeah. So here is the complete SQL statement as a result of the injection. So whereas it was expecting this to simply be 6, and then a quote, and then end paren, and then the rest of the SQL statement, we intercepted that. And so first thing is we just have to close off that first value, and we chose foo simply because we know we're not going to run in a user ID that has text in it. And then we can append that with or admin equals t. This is using SQLite. So Boolean values, I assume, they're set as a single letter instead of like a bit field or something. And then it's also important to use the comment field because the limit 1 and the rest of this is tacked on by Active Record. And if we didn't comment out the rest of the SQL statement, then it'd be an invalid SQL statement. It wouldn't run and our attack wouldn't work. So by injecting this piece of text, you can see how that now plugs into the overall SQL statement and enables that attack to happen. So the fix for this is to get rid of looking up the user like that and actually pull in the current user method, which is something implemented in application controller, which is pulling off the current user out of our session data, which means that it doesn't matter what user ID we'd like to modify. This code's going to make sure that all of our modifications happen only to us. And that means we're not able to take over an admin account. So there's our first attack. Any comments, questions, feedback at this point? So if you notice in the top 10 list, the number 1 item is not injection, or not SQL injections, but the number 1 item is just injection in general, because there are different kinds of injections. And another kind are command injections. And that's where we're modifying a statement that's going to be sent off to the operating system. And RailsGoat has that vulnerability as well, so let's look at that. Open up that spec. Go ahead and execute this one. Make sure that it passes. If it passes, that means the vulnerability still exists. So here's the attack. We have the normal setup, first of all, resetting all the users, grabbing a normal user account. Some additional setup for the attack is we're going to write off a file, a simple text file to public data, because that's where this attack is going to occur. In fact, if we look at public data here, it's currently empty. For demonstration purposes, I'm going to go ahead and just add a manual file. Go back. So the spec sets up that legit file, then we log in as a normal user, and then we go off and visit benefit forms. So let's look at that form here in the browser. I'm going to go back to the app, going to log out because I'm in as a hacked admin account. I need to go back to my regular user account. And we'll look at benefit forms. So benefit forms here has some files that can be downloaded and an option to upload additional files. And those files would be deposited in public data. So now for the attack. First, using the standard library tempter code, which is really handy when you need to throw off some files to a temporary folder. We're going to make a Hackety file, and you'll notice the unusual file name here. So the name of the file is actually going to be some malicious code that will be handed off to the system. We're going to fill the file with some text data that doesn't really matter, and then this code simply goes through the process with Capybara of attaching that file and uploading that file by clicking on the Start Upload button. And then because we have this code here that removes all files from public data, our legit file, which was added at the beginning of this, should now no longer exist. And if I go ahead and execute this spec, we will not see the legit file after we're done. Also, we should see the document.txt file that I added disappear. And in fact, there it goes. So to do this through the browser, I'm not going to do it in the browser just for time's sake. Basically, you just need to take this file name and create an empty file on your file system and upload that by selecting that file from out of that dialog and get the same effect. So the fix for this, we're going to go off to the benefits forms controller, and the upload action here is grabbing user data and is not doing anything to secure that data, to sanitize it, scrub it, or whatever. It passes it through intact off to this benefits object and its save method. Here's the file parameter that came in from the end user. It's concatenated here with the data path into full file name. So understand that full file name now has the tainted string data, and that gets passed into make backup. Make backup now receives the full file name. And you can see here's the crucial flaw, which is that's being concatenated into a command which is sent straight off to the system. So here, that full file name will basically execute anything that is passed in from the file name. And that's how this attack is able to happen. And the attack, you can see, is with semicolons cutting off one command and starting a whole other command. It's a similar thing to the SQL injection spec, where we needed to make sure we had this comment here so that when we're injecting this into the middle of a command, any side effects from the commands around it are isolated. So the fix for this is to just not do that. In addition to needing to sanitize the incoming data, it's just never a good idea to pass that off to the system. So if we're just copying a file, then in this case, it's safer to use file utilities and do the file copy. And so by putting that in place now, I can rerun the spec. The spec will fail because the vulnerability has been fixed, and we can go back down to public data and now see that the legit file still exists, and the file was simply uploaded directly as is, instead of that file name data being passed off to the shell. All right, so there's two injection examples. So let's go back to the top 10 list and see what else we've got. So the second item on the top 10 is a broad category of broken authentication and session management. Sessions are a crucial key to any of this security stuff, since we use that to cache any credentials so that we avoid the user having to re-authenticate with the website every time they load a new page. I'm actually not going to go into any examples here. One, because the RailsGoat example is a little boring. Basically, it's just a spec that ensures that you should not, on a failed login, inform the user why their login didn't work. We should not tell them that their user ID was bad. We should just say it didn't work, because we don't want to enable attackers to be able to enumerate what are good accounts, which can help their attack. There's some really good information, however, on some more complicated attacks, including timing attacks, which are ways you can still try to figure out what accounts are valid accounts, even though there's no messaging to that effect. This OWASP page talks a lot about this whole category of session management. There's a lot of different ways that sessions can be attacked. The Rails security guide as well has a lot of information. This document appears to be a little outdated, frankly, but still there's a lot of good information. This whole section on sessions shows many different ways that sessions can be hijacked or taken control over, abused in many different ways. So definitely encourage you to read through all of that. But because we don't have a really great example that's interesting, at least to me, in RailsGoat, and we're on a time schedule, we're going to move on. So number 3 in the top 10 is XSS cross-site scripting. We're going to look at an example of that in RailsGoat. So I'm going to go to the XSS spec. So one way to think of XSS, if it doesn't bring to mind what these kind of vulnerabilities are, is kind of, you can think of it as JavaScript injection. That's not an entirely accurate way of describing it, but that's one way that XSS kind of works. And so basically, this is just another example. Of course, a lot of these examples are apps not properly sanitizing the input data. So let's go ahead and look at this attack. Here's the spec. Again, we're resetting all the users. We're going to log in as a normal user. Then we're going to go back to the account settings page. If you remember, the account settings page is where we did our SQL injection attack. So there's another way we can mess with things, is that on this site, the data is not being scrubbed. So in our first name field, first name is being displayed here in the header of the website up here, welcome A. And since that's being displayed, if the input's not scrubbed, then we should be able to inject some JavaScript into it and have that JavaScript executed just by having that header displayed. So in this case, we're only going to do some minor defacing of the website. We're going to use some jQuery to find a button and change the text of the RailsGoat tutorials button to RailsGoat Hacksword. I'm going to run this spec to make sure that that passes, meaning that the site is vulnerable. And it is, and then we'll demonstrate this here in the browser because it's pretty simple. I'm just going to copy that string right there, replace that, submit my form. It was successful, and now by reloading the entire page, that header is re-rendered. And notice that by putting B in the first name, we still get that, but the rest of that script was actually executed, and now the RailsGoat button has been hacksword. And of course, now that the site is executing our JavaScript, we could do all sorts of bad things with that JavaScript. So the fix in this case is somewhat Rails specific. If we go off to one of our shared partials, we're going to look at the particular cause of this one, which is this method called HTML safe. It's kind of a confusing name. I know when I run across it, I tend to think of it indicating that it's my way of telling Rails, hey, I want you to render this in a way that's safe. I want you to escape any tags that are in this data. I want you to make sure that it's safe for me. When in fact, it's the opposite. The HTML safe method is my way of telling Rails that I'm confident that you can render any of the tags or anything in this data for me. So it's very important to understand what this method does, and anytime it gets used, to not just throw that around willy-nilly and say, well, it says safe in it, so it must be safe for me to put it in there. So in fact, this fix in this case is to remove that. Obviously, we would also probably want to be sanitizing the user input within the controller, but in this specific case, this is really all we need to do. And by removing that and refreshing the entire page, we can see now that that script is no longer being executed, but just being inlined here in the display of the header. All right, so that's the example of cross-site scripting. We're about a little over halfway through. So let's see if I need to skip any. And we'll do this next one. So number 4 on the top 10 list is insecure direct object reference. Direct object reference is kind of broad. It really can mean just anytime we're directly accessing either a file, directory on the file system. Sometimes it's accessing other pages or routes within the application that we shouldn't have direct access to. We're going to see one example of both of those. So go to the insecure door spec. So the first one's actually going to access files directly on the file system. Excuse me. So we're going to reset again, log in as a normal user, visit the benefit forms this time. Go back off to benefit forms. So last time we attacked through uploading, this time we're going to attack because of a vulnerability for downloads. The spec here grabs the download URL from one of those files and takes that URL and then just substitutes out the file name they want me to grab and replace it with config database YAML. And is able to successfully down that. That's very easy to demonstrate here in the browser as well. Right-click that, copy link address, paste that in here. Before submitting, come in here and say, I don't want that PDF. I'd like config database YAML. And sure enough, it downloads that for me. And then I can open that up in my text editor, and away we go. And of course, then there's no protections as well on, hit the wrong thing here. There's no protection on parent directories or absolute paths, so you could actually pull off any file off your file system through that vulnerability. That particular fix is in benefits controller again. So again, the download, the problem here is we're just taking in user input and not sanitizing it. So a more secure version, now this is contrived for the sake of this example, but in this case, we're now in control of the files that are being accessed. So you have to request one of these files, otherwise I'm not going to give you whatever file you ask for. And so if we do it that way, then we're better off. So that's one example of an insecure direct object reference. Another example is where we're not re-authenticating the user. And this is not exactly completely, well, sorry, it's not authentication, it's authorization. So if I'm on the work info page, this path includes my user ID. Well, it turns out I can just put any old user ID in there, and there's nothing preventing me from looking at other users' data. So again, I'm directly accessing the objects. I'm not having to hack anything. This is simply the web application letting me have quick and easy access to those things. And this is another example of the same vulnerability on the SQL injection, which, so if we go to the work info controller, you can see that it's just looking up the user ID out of that route, not tying that to your session at all. So what we should be doing is tying that to the session. And so if I put this fix in here and hit refresh, you'll notice it's going to go back to me, my account, even though there's 2 up there, because it's not caring about that 2. It's tying it to my session. All right, so that's it for insecure direct object reference. Number 5 on the list. Should have got some KCK, some drops or something for entertainment value. Number 5 is kind of a broad category as well. It surrounds security misconfiguration. As you can see in the OWASP description, that includes platforms, web servers, app servers, database, et cetera, et cetera, et cetera. In a lot of cases, certain apps or platforms will have insecurities by default. So it's important to understand all those things and make sure things get into a secure place. In this case, we're going to be looking at a mass assignment problem. So I'm going to look up the mass assignment spec. RailsGoat is a Rails 3 application, and between Rails 3 and Rails 4, some things around mass assignment, strong parameters, whitelisting with adder accessible. Rails 3 had one way of doing it, basically focused on the model. Rails 4 switched over to strong parameters, which took it out of the model but put it into the controller, which offered some more flexibility so you didn't have to complicate your model by having different contexts, whereas in an admin context, you may want to have more access to attributes and in a regular context, not. By pushing that with the strong parameters into the controllers, that lets each controller kind of decide that, and the model can be ignorant of those things and put the protection there. I don't have time to really go into all those details. Suffice to say, if you're on a Rails 3 app or going to be moving to Rails 4, do some research around adder accessible and strong parameters. These things are gemified as well, so you can swap them in and out. You're not tied to a certain approach for a certain version of Rails. So in this attack here, for mass assignment, we're going to, again, create an admin account simply from our normal account because the update is not guarding against that. So you can see that we reset, log in as a normal user, and in our params simply say, yes, please, make me an admin. And by submitting that and we reload our account, we're able to update our account into an admin. We can also just straight up create a brand new account as an admin. And I'm going to demonstrate that one from the browser. Actually from the browser and with curl, because it's more fun that way. So I'm going to log out completely, go to the sign up page, and use a new account, b@b.com, because I'm really creative that way. Now before I submit this, I'm going to open up the Dev Tools and go to the Network tab. This red button here means we're recording. Clear this prior recording. Now I'm going to go ahead and submit. And that's just created a normal account, so we've not attacked the site. But in doing so, we've captured a regular submit. And one nice thing, I think a lot of the other browsers have this now too, but we can copy this post as a curl command and then go off to our console. And here we can now resubmit this curl command with some slight alterations in order to give ourselves an admin account. So first thing I need to do is make a different email address because it won't let me create two accounts with the same email. So I'm going to change that to be c@c.com. And then by appending a bit of text, let's see, I'm just going to type this. We're going to do and user admin equals t. By adding that in there, we're using the parameters hash to say, yes, I want you to also make this user an admin. And I've submitted that. No matter what, that submit always results in a redirect. So to verify that this worked, we'll go back here, log out, and then log in as c@c.com. Password is password. And it did work, and we're in as an admin again, when we shouldn't be able to do that. So the fix here for Rails 3 is a couple options. So application.rb has this active record whitelist attributes. I can't remember if by default in Rails 3 if this exists, if it's turned on, if it's turned off, I don't recall. But anyway, in RailsGoat it's turned off. So we need to turn that on. And the other problem is that in the user model, so this adder accessible works in conjunction with this active record whitelist attribute setting. If that's set to true, then it's going to pay attention to these values. And unfortunately, they left admin as an accessible for mass assignment, which helps enable this attack from happening. So if I go back to the mass assignment spec and rerun the spec, it should now fail because of a mass assignment protected attributes is not allowed. I could also reattempt this curl command with a new email address. I'm going to do d@d.com, and you can see that instead of getting redirected, we get a big blob of fail. And so that vulnerability has been patched as well. All right, so that's it for our example for misconfiguration. About 10 minutes left. I'm going to hit invalid access control real quick, not go into as much detail as I'd planned. Go back out to the top 10 list. Number six I skipped also for time. So it's pretty simple. You can read the tutorial yourself if you're interested. So missing function level access control. This basically means we're not reauthorizing. If you fail to reauthorize your user every time they go back to the app, then you can miss out on some stuff. So as an admin, which I think I still am, as an admin, if I go to manage users, you'll notice my route here is admin1 dashboard. I'm going to put that on my clipboard. I'm going to log out, log back in as my regular user who's not an admin. Because that route is actually not validated properly, I can paste that straight in and get direct access to the admin dashboard even though I'm not even logged in as an admin user. And the problem in this case is in the admin controller. At first glance, it may seem weird because they have a before filter that's calling this administrative function, and this administrative function is accessing current user, which is based out of your session. So all of that looks legit, but there's an exception. Somebody decided that, well, we only need to do that filter if we don't have an admin ID of 1, because everyone knows that admin ID of 1 is, of course, an admin. So there's no reason to go to all that trouble. Of course, it's not any trouble, but there's no reason to go to all that trouble to check if they actually have the privileges, because we know that admin 1 is fine and that person should just be whitelisted in. But of course, that enables a big security hole, and anybody can put that route in there and get in there. So the fix is to simply remove that. And now, still logged in as a regular user, if I refresh this page, it's not going to allow me and redirect me back to the dashboard home. All right, so that's number 7. Number 8 on the list is, I guess the security folks will pronounce it as sea surfing, because that's fun to say. It's actually CSRF, cross-site request forgery. So the second one here, broken authentication and session management, is all about the attacker trying to gain access to your session and then doing things with your session, impersonating the end user. CSRF is kind of different in that it's trying to get the end user to do things for the attacker, where the attacker does not need to gain access to the session at all. The attacker can simply say, hey, you do it on your session, and that way I don't even have to mess with that. So let's look at the spec on this one. So the spec here is a normal reset. We visit the root so that I can pull out the base URL for the site. That's something I couldn't figure out how to do in Capybara without visiting it first. So that's just a little bit of administration work. We log in as a normal user and then go off to a temp directory to make our Hackety file. So what we're going to recreate is a form on attacker site, and this form HTML is essentially a copy of, let's see here. Sorry, I lost my place. It's a copy of the PTO form. There we go. So if we go to inspect element, of course this form's a little more cluttered because it's got markup and whatnot for layout. But essentially the guts of this form is the guts of this form. So the attacker is going to recreate that form, putting in their own data. And then for this attack to work, the attacker needs to get the end user to be able to visit that form somehow. In our little contrived example, we're just going to visit it on the file system, get that form to be submitted, and then the form's going to be submitted to the real destination URL, and then the web app processes that on whatever the current user session is. So the attacker never needs to get access to the session. So if we go out to the browser, we can see this in action. I've got this file sitting on my hard drive. So just by clicking submit request, we can see we get some JSON back saying that that was successful. And now by going back to my PTO, suddenly the attacker person has put a 10-day vacation on my thing. Now, of course, in my case, I would prefer that attack. That would be okay by me. But that just demonstrates how an attacker can control stuff. If you had a bank form that didn't double check where the form was coming from, then the attacker could use that to, for example, transfer funds from your account over into theirs. So to patch this up, we need to go to the application controller. So the Rails way of dealing with sea surfing is protect from forgery, which they've disabled here as a way of showing the vulnerability. So if we look at this form, there's a couple things here. Now I'm going to go to view page source. So in application HTML ERB, in the header for all of the pages here, this view command CSRF meta tags creates this authenticity token in the header, as well any form that's generated by Rails that's not monkeyed with will also have an authenticity token. So this page has one in the header as well as within the form, and this token is generated to be very difficult for an attacker to recreate. And by having protect from forgery enabled in your controller, you look at that code, protect from forgery is going to prepend a before filter called verify authenticity token. And verify authenticity token has a few more methods. I don't have time to dig through all of it, but basically it's going to take those tokens out of your form and verify them against your session. Those tokens come from your session data, and it should be very practically impossible for the attacker to fake one of those tokens. So if we look back at the CSRF spec, the attacker's form would have to put that token in here, and it'd have to be based on your session now. And the whole point of this attack is to be able to attack your data without needing to get access to your session. If they could get access to your session, then they've got other ways of attacking you that are probably better than this one. So by putting that token in there, it can verify it. And so now that I've re-enabled protect from forgery in my application controller, if I go back to the browser, load this file locally off my hard drive, and submit request, it's in fact going to reset my session. So the session's gone. Any authenticity tokens that were put out there are going to be invalid now, and then redirected to the home page. And now that attack has been thwarted. All right, so we're almost out of time, and that pretty much covers most of what we got. Again, the goal here is really just to introduce this tool. It's a nice tool to understand how all these vulnerabilities work. Security certainly is a deep topic. It's important to have experts you can rely on, but security is also everyone's job. As we've seen, some of these vulnerabilities came from perhaps well-meaning improvements or enhancements to the code, but unfortunately left the door wide open for attackers. So it's a good tool. I like it. We've only got a few minutes for questions.
Some good ooh-and-ahhing over the
before they kick us out of here, but go for it if you got any questions.
I think that was the best pickup I got.
Trevor, if you don't use the Rails form generators, you're still vulnerable to CSRF, though. Yes, even with protect from forgery on. I'm not sure. I know that meta tag's in the header, so part of me